This video covers section 1.2, types of data. In section 1.1, we learned how to collect data through various sampling methods. In this video, we're going to learn how to classify the data that was collected. First, a couple of terms. An entity whose data is being collected is an individual. Characteristic of an individual that can be measured is called a variable. Note that I didn't say quantify because we can have qualitative variables too. The information collected about a variable is data, and the collection of all data is a data set. So now let's look at the following data set that I just took from the book. Remember, we should always be reading the book. So look at this chart for a second. We've got movie titles, release year, studio, ticket sales, runtime. And just look at the question down here. Try to identify the individuals, variables, and data. Pause the video and try to identify the individuals, variables, and data. The individuals are the movies that are being considered. Actually, let me not include the numbers. I'll just look at these guys. These are the individuals, right? We found the top 10 grossing movies. We ranked them in that order, and we want to collect data on them, right? The variables are just the things that are being measured. Yeah, the movie title counts as a variable. So to release year, studios, ticket sales, and running time, all of these are variables. And then the data is just the info that we collected about these, right? All of this stuff, that's all the data for release year. This is all the studio data. I think you see where we're going with this. Ticket sales data. And, of course, runtime data. All right. So there we go. Now, categorical or qualitative data, or variables, I should say, are variables whose data categorizes individuals but isn't numerically measured, right? So these are variables that are measuring properties or characteristics that are not numerical, as opposed to, well, let me try that better, quantitative variables, right, or numerical variables. Variables whose data is numerical, right? A characteristic that is quantifiable or numerical. And we'll look back at this example for examples of each. Okay, now first off, two subsets of qualitative variables. First off, there are what we call nominal variables, which have no natural ordering, right? They're just names, right? Nominal means names. Next, ordinal data, or ordinal, I should say, variables, do have some kind of an ordering. But they're both qualitative types of data. They're both qualitative types of variables. So, but because they're qualitative, neither, I shouldn't say that. I'll say neither intervals nor ratios are meaningful, right? And when I say addition, I mean addition and subtraction, and for ratios, I mean multiplication or division, right? Those operations are just not meaningful when we're talking about these kinds of variables, okay? So in example 1, mark the columns for nominal or ordinal variables. Pause the video and see if you can do it. Movie titles are actually ordinal variables. Now, of course, without the rankings, they just would have been nominal. But because we have these rankings, etc., they're ordinal. Okay. there is one other nominal variable. You see that? It's the studio, right? It's just a name. There's no ordering to this. You could alphabetically order them if you wanted, but that's not what we're doing. Okay? Nominal. Now, one question you might be wondering, I was wondering this too when I first learned about this, ordinal variables use orders, right? 1, 2, 3, 4, 5. Why aren't they numerical? Why do we classify them as categorical or qualitative? And the reason is, well, you could think about rankings as being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or you really could replace the numbers with letters, right? A, B, C, etc. up through J, right? You don't actually need numbers, right? Again, think about it in terms of mathematical operations. It doesn't make sense to say, this movie was 3 places higher than that movie, and that has some kind of a numerical connotation. It doesn't. We don't know how much more ticket sales that movie had just based on their ranking. It doesn't mean anything. So we'll say ordinal variables. I guess I would say do not produce meaningful data when, I'll say, numerical operations are performed. For example, plus, minus, multiplying, dividing. So they're not numerical, right? I guess I'll just say further, I guess I'll say order placement could use letters instead of numbers. Right? There are also 2 subsets of quantitative variables. Now, this, by the way, is a little niche. You won't need to know it's for Friday's quiz, so if you want to, you could skip ahead 30 seconds in the video, but I think this is worth knowing. Interval variables, you don't see these all that often, have the property that the value 0 does not imply 0 quantity. And so for this reasons, intervals are meaningful, but ratios are not. And lastly, ratio variables have the property that the value does imply no quantity. And so for this reason, both intervals and ratios are meaningful. Right? So if we go back to example 1, an example of interval data is, do you see it? It's the release year, right? Why? Well, there is no year 0, but even if there were a year 0, it would not represent the beginning of time. 0 does not represent the beginning of time. So while we can say, oh, Avengers Endgame came out 10 years before Avatar, that makes perfect sense because 2019 minus 2009 is 10, it doesn't make sense to try any kind of ratio with those years because it wouldn't be accurate because ratios depend on 0 meaning 0. Now, where's the ratio level data? Well, here we go. Ticket sales and running time, right? It does make sense to say that Avengers Endgame is almost twice as long as Frozen 2. Or that Avengers Endgame grossed almost twice as much as Frozen 2. Ratios do make sense in that context. Okay, so the variables are ratio variables, the data is ratio data. So, just a little fact, you don't see interval data too often. So just to let you know, date and temperature are the 2 most common interval variables. Another example could be if you're into sports, boxing and mixed martial arts, the 10 to 9 scoring system, that's interval level data, as is gymnastics and probably figure skating scoring, where, again, interval comparisons make sense, but ratios just don't. Okay. Also, this is more important regarding quantitative data. Quantitative data is also divided into, put this one first, discrete and continuous variables. A discrete variable has values that can be listed, while a continuous variable may take on any value within an interval. And I feel a lot of times these definitions may not make a whole lot of sense until you see an example. So let's look at an example. Right, pause the video, read example 4. Which of the variables in example 4 are discrete or continuous? Well, we see shoe sizes and the time it takes to commute. Okay? So here, shoe sizes are discrete, right? Because you have 1, 2, 3, 4, 5 shoe sizes. You don't really have fractions of shoe sizes, right? So they can be listed. While commute time is continuous, right? Because time isn't just listed, it's this continuous entity. It could occur within, if I give you an interval of times, any possible time within that interval is a legitimate commute time. Okay, so those are just 2 examples of discrete and continuous variables, and that's what we've got for today.